Hello guys, so I want to continue where I ended with the question I started answering, which is question 2a, Roman numeral number 3. So we have been given the balanced reaction. I balanced the reaction. I've been given this data. This mass was provided in the question and this mass was provided in the question. Then I calculate the number of moles for copper 2 chloride. Of course here it was 0.1111. That's what I calculated, but I went through, I found there are two numbers, which is 5, 6. So when I rounded it off, it gave me 0.1116 as the number of moles for copper 2 chloride. Yeah, then the number of moles for copper 2 nitrate, or for sodium nitrate, I mean, it's this one. So the question is asking me to find the number of grams, like the mass for copper 2 nitrate which was formed. So for me to find the number of grams for this one, I'm going to compare this one with a limiting. We always compare with a limiting. So the limiting is copper to chloride. I'm comparing it with copper to nitrate, like this. So, okay, before I even go to number of grams, first let me find the number of moles which was formed. If I find the number of moles, I'll convert those number of moles to what? To grams. Yeah. So I'll do a comparison between this one, what was formed, with a limiting. That's what we always do. So if I find that the mole ratio is what? 1 to 1 ratio. I'm having 1 here and also what? 1 here, which is 1 to 1 ratio. That tells us to say whatever number of moles we had. For example, I say copper 2 chloride, I know the number of moles is 0.1116 compared with this one, which we don't know, which we are calculating. This is x. Whatever we're going to find, it was, let's say x is equal to 0.1116 moles of copper 2 nitrate. Because of being the mole ratio is just 1 to 1, that's why the number of moles are the same. Yeah, so this is what we do. After finding the number of moles, now let's convert this number of moles to what? To grams. So we'll say number of moles is equal to mass over what? Molar mass. We are looking for grams, which is mass, is equal to number of moles multiplied by what? Molar mass. So number of moles, we know it's 0.1116 multiplied by molar mass. Let's find the molar mass for copper 2 nitrate. So copper 2 nitrate, this is 3. So you can do like this. Oxygen we have 3, but it also have this 2 which is outside. So 3 times 2 is 6 multiplied by its mass number is 16. Then nitrogen also is having this 2 outside. So we have 2 multiplied by 14.01. Nitrogen have a mass number of 14.01. Then copper is just having, we only have one atom of copper multiplied by its molar mass, or its mass number, which is 63.55. Let's add up these numbers. What are we having? So we are having 187.57 gram per mole as a molar mass. So we come here and replace 187.57 gram per mole. Remember here there is more, so more and more will cancel out, remain with grams. So the number of grams, if I multiply with that, what am I having? I'm having 20.07 20.93 grams of what? Copper 2 nitrate. And you are done solving this question. So these are the number of grams for what? Copper 2 nitrate, which was what? Which was formed. Yeah, this is how you answer it. So now we go to number 4, question 2A 4. Remind me number 4. So the question was asking us to find the number of grams of excess reagent which was left over in the reaction. So how do we find the number of grams for the excess reagent? So before I even go to that, I'll talk about the number of moles first, which was what? Left, the leftover. So I'll say leftover, it can also mean what was remaining. So I'll say the formula is like this: moles remaining is equal to moles available minus moles used. This is the formula of our finding the number of moles which was left over. After we find the number of moles which was left over, that's when we are going to find the grams. We'll just convert to grams. So now let's continue. And by the way, we're talking about sodium nitrate. So what are the number of moles which was available? When we talk about the number of moles which was available, is the number of moles you get before dividing by what? This balancing figure. Yeah, this is a balancing figure. Don't put that into consideration when you're looking for number of moles which was what? Available. The number of moles which was available before dividing by these two, we had something like we get something like 0 point 0 point what, that one, 0 0.23, it's here, this one. This is what we get before dividing by that balancing figure. So 0 0.253 minus the moles which was used is when we divide by the same this balancing figure. And what did we get after dividing? We can actually divide here. The number of moles which was available for the excess is this one, 0 0.2353. Then the number of moles which was used, now we start comparing with the limiting. You compare with what? The limiting. So if we compare the ratios, we're having 1 to 2 ratio, which means, for example, this is 1 to 2 ratio. Copper 2 chloride has 1, sodium nitrate, which is an excess, has 2. So we are looking for number of moles which was used. We don't know, we put x. Then here we know to say it was 0.1116. So when multiply, we find that x is equal to 2 multiplied by 0.1116. So x is given as, let's try it. So having 2 times 0.1116, we're having something like 0.2232. So come and replace it here. 0. This are the number of moles which was used. So you compare with a limiting like that. So what are we having? So 2353 minus 0.232. giving us something like 0.0121 moles. We're talking about moles. Now let's convert this moles which was remaining for the excess. We convert it to grams. We have been asked to convert to grams. So we know that number of moles is equal to mass over molar mass. We are looking for mass. Mass is equal to number of moles multiplied by molar mass. We are looking for number of moles we have found, which is 0.0121 multiplied by molar mass. Molar mass for the same excess reagent without considering 2. Don't include 2 when you're looking for molar mass as well. So for sodium nitrate, we calculated the molar mass. It is what was the value? Let me look for it. We can just actually calculate. Let's calculate. We are having sodium nitrate. Oxygen, we have 3 atoms of oxygen times 16. It is a mass number. Nitrogen, we only have 1 times 14.01. Sodium, only have 1 times 22.99. What are we having? This is 48 plus 14 plus 22.99. It's giving something like 85. Yeah, 85 gram per mole. So let's put 85. So what are we having when we multiply this? So it's giving something like 1.0285, which is just 1.03, rounded to 2 decimal places, grams. This was the number, the grams which was left over, for the excess reagent. First of all, find the number of moles which was left over, means which was the number of moles which was remaining. So say the formula is like this: moles remaining is equal to moles available. The number of moles for this excess reagent you found before considering the Vist balancing figure, which is 2, you find, which is this one. Then minus the moles which was used. Now, for you to find the moles which was used, you compare with what? The limiting. The ratio is 1 to 2. So you have 1 to 2. Now, you know the number of moles for cobalt chloride which was used, this one. To what? To X. That's what you are looking for. When you cross multiply, you find that your X is this. So this number of moles are the one which was what? Used. Then you just subtract. After subtracting, convert this number of moles to what? To grams. This is what you have done. You should have calculated the number of grams which was what? Left over for the excess reagent. Yeah.